this video, we're going to cover pages 5 and 6, so this video might be slightly longer than the last couple. But let's hop right in. So here we have the differential equation y double prime minus y equals 3t squared. First thing you always have to do is find your complementary solution. So that means that we're going to pretend that there's a 0 on the right-hand side and try to solve that, right? So the way we would do that is we would get r squared minus 1 equals 0. That's r plus 1, r minus 1 equals 0. So r equals 1, minus 1, r equals 1, okay? And so yc is c1 e to the minus t plus c2 e to the positive t, right? Okay, so nothing crazy going on there, I hope. Now what we're going to do is, well, if we were in class, I would have the groups kind of get up and work this out on the board. But we're going to take a guess as to what the form of the right-hand side should be. You'll notice that I just have a t squared here, so it's tempting to say that maybe 1 is the right thing to do because it looks pretty much the same. And like when we had something like e to the 2t or something like that, this was the form. But in fact, this is not going to be good enough. It's also tempting to say, well, 2 adds a little bit to that. Maybe that's good enough. I saw in the last example with the sign that it also needed a cosine, so maybe throwing an extra term in there with the power of t, or t to the first, is good enough. Well, that's also not going to be what we need. It's actually going to be case 3. So pretend that you had some enlightening moment during class that revealed this for you, but we're actually going to do that right here. So let's take our quote-unquote guess here, which I'm telling you what it is, but let's work it out and see if we can find what a, b, and c have to be. So now what that tells us, finding the derivatives, this tells us that the right-hand side, which is 3t squared, has to equal y double prime, which is 2a, minus y, which is at squared, plus bt plus c. And you simplify, and you get minus at squared minus bt plus, now the constant will be 2a minus c. And so what that tells us is now we need to equate coefficients, right? So the coefficient of t squared has to be the same. The coefficient of t has to be the same. Notice there is no t, so over here the coefficient is 0, so that should help us find what b is pretty easily. And also the constant coefficient, well, there is none over here, so that means that 2a minus c is also 0. So what we get is 3 equations now, so 3 has to equal the minus a, 0 has to equal the minus b, and 0 also has to equal 2a minus c, right? So a is -3. I think that's pretty clear to see. B is 0. And now c, if I just add c to both sides, c is equal to 2a. Well, if a is -3, then that is c is equal to -6, right? Okay, well, that's pretty much it. We get yp has to equal minus 3t squared, so a times t squared, and then plus 0t, and then minus 6. Well, that's, just simplify that. That's minus 3t squared minus 6. And so now the general solution is, once again, the complementary plus the particular. So that is c1 e to the minus t plus c2 e to the t minus 3t squared minus 6. Notice here we're adding yp. Well, both of these have negatives, so we preserve those. Okay. So that's it for this page. Let's move on to the next one. Let's take a stab at A and C, and go ahead and try B and D if you like. We're going to get to those in just a minute. But part 6, I think or 6A, I think we saw that the right-hand side is probably going to have the form yp equals a cos 3t plus b sine 3t. So review the last video if you need to, but anytime you have a trigonometric sine or cosine term, you need to take both sine and cosine of that type. Okay. Coming down here, well, above we dealt with a t squared term, and we had to use all of the full polynomial, at squared plus bt plus c. So something similar is probably going to happen here. I think a good guess would be yp equals at cubed plus bt squared plus ct plus d. Right? All right. So let's talk quickly about the principle of superposition, and then we'll get to answer part B and D. All right. So what we're going to do is, let's suppose now, so let's get the highlighter here. Let's suppose now that the right-hand side is actually two functions added together. So no longer just one, but two functions. So something like this, right? Then if you can solve the differential equation where you just have one of the terms, and you can solve it where you just have the other of the two terms, then let's say x1 is the particular solution that you get when you solve it with just, let's say, the first f1, and x2 is what you get when you solve it with just f2 on the right-hand side. Then, well, I should say that the reason is because this is really technically xp1, right? But that's kind of cumbersome to write. So it's easier to just write x1. Anyway, the point is that really what you can do, and this is what superposition is, you can just take the complementary solution and add each of those individual particular solutions. And that'll be the solution of when you have both of them added together on the right-hand side. Okay, so if you look back a few pages, if we have this differential equation now, we actually solved it for each of these individually, right? We had the 3e to the 2t, and I think we had like a 1 over 11 e to the 2t when we worked it out. And then here we had something with sines and cosines. So what that tells us is now, if I just add those two from our previous work, then that's going to give me the solution to this new one. So this is c1 e to the minus t plus c2 e to the minus 9t plus 1 over 11 e to the 2t. That one corresponds to this. Plus, and now you remember we solved it actually with the negative. So technically these are being added because it was this one plus the negative 85 sine 2t. So we're going to add here 4 cos 2t minus sine 2t. And now this one comes from that one, right? And that's all there is to it. So that's a nice, I guess, property of linear differential equations, is the superposition property. Now let's use this to help us find B and D for number 6 above. So, so 6b, well, let's work using the principle of superposition, and we'll kind of learn something here. So this one, the 6 sine 2t, well, its form will have to be a cos 2t plus b sine 2t, and so will this one as well, right? Each of these is going to have a constant times cosine of that inside and sine of that inside, 2t in this case. And so here's what I want. I'm going to actually save the constants a and b. You'll see why. So I'm going to say, to solve the thing with the sine first, that's going to be c sine cos 2t plus d sine 2t. And then to solve the one with the cosine, that's going to be e cos 2t plus f sine 2t. Right? And now, by the superposition principle just above, that means that the particular solution is just going to be the sum of these two. So what you get is you get c plus e cos 2t plus d plus f sine 2t. Well, if I just call this a new constant, let's say a, and I call this a new constant, let's say b, then really the particular solution just has the form a cos 2t plus b sine 2t. Interesting, huh? So it didn't matter that we actually had two terms of the same type, right? As long as they're of the same type, this one is a constant times sine 2t, this one is a constant times cos 2t. The form of the solution is still going to be a cos 2t plus b sine 2t. And now, maybe you can see where this is going for this one as well. Let's work it out below. But for 6d, well, our first term is a t squared, and we know from just a couple, well, right here, I guess, if you have a monomial term, it's just start with that highest power and then count down, right? So in this case, you started with t cubed and then went down to the constant term. So for this monomial term, t squared, we're going to have at squared plus bt, and now I'll save the constant c, and I think you can kind of see why, plus d, and now go all the way back to the very first video here, if you like. Now we have a constant term. Well, I think the answer to a constant term for the particular was just another constant term. So this one I'll call e, right? And now by the principle of superposition, my new particular solution is just the sum of those two. Well, that's at squared plus bt plus, well, I'll say d plus e, right? And now I'm just going to call this a new constant, c, right? So in fact, it's at squared plus bt plus c. And so what we observe is that if you have a polynomial term on the right-hand side, then you just start with the highest power, and doing this, counting down, actually captures all of the lower powers that you might encounter as well. So that's nice. You don't have to, like, I don't know, do it more than once, right? You can just capture everything by giving yourself a quadratic in this case, right? All right, so that's the end of this video. We will pick up with page 7 of the notes in the next video.